All right, here we go. Let's take a look at some U substitution. So we're going to kind of get to some more advanced techniques here for integrating. So let's say we want to integrate this thing right here. We're going to dive right into it, and then we'll kind of talk about why it works here. We're going to do something called U substitution. So I've got this mess right here because it's raised to the 5th power. So that's kind of a bummer. What I can do with it is we're going to make it look easier for us. So I can say, okay, let's pretend that U is that mess on the inside. So let's pretend it's the 3x minus 4. And what's nice about this is I can take the derivative of U with respect to x. And if I take the derivative of this, what do I get? I get just plain old 3, which is pretty cool. So what do I really want here though? So I want to start subbing these things in. So I want to rewrite my integral so it looks nicer, so I can say it's the integral. Well, I know U is the 3x minus 4, so that's going to be U to the 5th power. But I don't quite know what dx is, but it's over here, so I can actually solve for dx. I can times both sides by dx and say, oh, hey, those cancel, so du equals 3 dx. And then what can I do? I can say divide both sides by 3. I'm looking at 1/3 du equals the dx. So what's cool about this is, see the dx right here? What is dx equal to? It is equal to 1/3 of the du. So what did I do there? I put everything's in terms of U. That's why it's called U substitution. And this is great for me. So what do I like to do here? Well, to clean this up a little bit, I like to go ahead and pull constants out. So that 1/3 can actually come out in front of the integral. So it's just a constant. So this is really what I'm looking at here. So this is nice looking now. This is something I can integrate no problem. What do I got to do? Well, let's go ahead and integrate it. So I'm going to bump the U up to U to the 6th. Then what do you got to do? You divide by that. What do you have to do? U substitution. And then I still got the 1/3 out in front. And what do I have? I introduce some constant c. So technically, really speaking, it's this. It's 1/3 times everything. But what happens when I distribute that 1/3? Well, I'm going to get 1/18 U to the 6th. What's 1/3 of c? Well, c is a constant. It's just 1/3. So it doesn't really mess with it when I put the c in there. Am I done? Well, let's bring it back into, I started in x, so I should have ended back in x. So what am I going to do? Well, I know u is 3x minus 4, so I'm going to replace the u with 3x minus 4 to the 6th power plus some c. So there it is right there. So we can kind of, this is something I couldn't integrate because it's got essentially got some chain rule action going on in here, but this is the antiderivative. So we're going to spend our time finding antiderivatives. Awesome. Very nice. Let's try it again. So anytime I'm going to set one of these bad boys up, I kind of look for the grouping symbol. In this case, it's a parentheses, and I usually look for the worst looking thing. So I'm going to take this, and I'm going to say, what is u? It is x cubed plus 4. And then I'm going to take the derivative of u with respect to x, and I'm going to get it's 3x squared. So is that good? Sure. Yeah, I can start to see this matching up already. Like, hey, there's my 3x squared. There's my u, so I know I'm in good shape. Let's solve this again for dx. That's our ultimate goal. So I'm gonna kind of do this. So the du equals 3x squared dx, and then I'm going to divide by 3x squared. So really, dx is this du over 3x squared. So when I go to rewrite this bad boy, what's going to happen here? So I'm going to have 3x squared. This is my big u substitution. Maybe I should go to red. So this is the same. I kind of use a similar one to the first one. That's u to the 5th, the x cubed plus 4. Then what is dx? Dx is du all over 3x squared. So at this point, all your x's need to cancel. So if they're not canceling, something's going on here. So check it out. 3x squared cancels 3x squared. We know we're good to go. So really, this is just the integral of u to the 5th du. Pretty cool, huh? So now we can go ahead and take the antiderivative. So bump it up, divide, and that's going to introduce some constant we don't know, some c. Let's finish it out here. So I got to go back to terms of x. So it's really going to be 1/6. Replace the u with this x cubed plus 4, and that's all to the 6th power plus c. So there's the antiderivative right there. Boom! Nailed it. All right, let's do two more of these. And I know this is kind of weird at first. Maybe you're blown away but right now. And this is one of the things you just got to practice, practice, practice. So let's try to set this up. So I've got a grouping symbol now as a square root. So the chances are I'm going to take whatever's inside my grouping symbol. And the derivative, so a lot of times we just skip straight to du because I know I'm going to multiply by dx on both sides. So this is kind of lazy man's version here. So the derivative of 4x minus 5 is 4, and then we just say dx. So a lot of times if you're looking at stuff, this is just my u and du because we're going to need to get there anyway. Awesome. Now I'm going to go ahead and solve for that. So I'm going to solve this by dividing by 4. So I've got this du over 4 equals dx. So now let's sub these bad boys in. So I've got the integral of what? U to the 1/2 power. What is the dx? It is du over 4. But we don't like that. That constant we can pull out front. So I'm really going to say it's 1/4 the integral of u to the 1/2 du. So we're going to pull that constant out. It didn't cancel anything in there. So we're good to go. Let's go ahead and take the antiderivative of that. So I'm going to bump it up. So 1/2 bumps up to 3/2. I'm going to go ahead and flip it or divide by that. So I get 2/3. Don't forget your 1/4 out here. And I'm introducing some constant out here. Boom. There it is. So once you get everything subbed out, it's just our rules. It's not too bad at all. It's just that kind of initial setup of the u here. Let's finish it out. So I can go 1/4 times 2/3 is what I can say that's going to be 1/6. So that's nice. So 1/6. And u is really, let's say u is, I'm going to go ahead and put it in, this is the square root of what? 4x minus 5 cubed, and then I'm going to square root it plus some c. So I subbed all that back in. There it is. Wow, this is awesome. Pretty cool. So now we can start taking square roots and things like that. Holy cow, let's look at the next one. If you want to pause it and try it, that's cool. If not, you want to watch with me, let's do it together. So what I'm going to look at u, there my grouping symbol on top. I'm guessing this is it. A lot of times it's guess and check. I don't know if I'm right. I'm just going to try it and hope it works. As you get better, you can kind of work ahead and you can kind of see what's going to happen, hopefully. So again, let's go straight to the du. The derivative of this, well, the derivative of x to the 1/2, remember, is what? It's 1/2 x to the negative 1/2. Remember, x to the 1/2, you bring the power down, subtract 1, and this is with respect to x. Very nice. So what does this really mean? So what do I got going on here? This is kind of weird. Let's rewrite this so we can see all the steps here. The negative 1/2 puts it on bottom, so I'm really looking at this. So is that good or bad? I don't know. I got to solve that for the dx. So I'm going to, what, times by this on both sides? 2 radical x. Why am I doing that? They cancel, and I'm left with my dx over here. So I'm looking at 2 radical x du. So if everything went right, when I sub it in, it's all going to kind of magically cancel out. So I definitely know I can take this u here, that was the part, and make it u squared. And I'm going to do this in chunks here. I'm still left with the square root of x on the bottom. And then dx over here, I'm going to cancel. I'm going to cancel in green. So in green was the dx. It was this 2 radical x du. And again, things got to start canceling here, or else I've got issues. So luckily the x's cancel out, but I'm left with this extra 2. Remember, but that's cool. That constant just comes right out. So it'll be 2 times all that. Looks just like that. So that hot mess right there turns into that pretty little thing right there, pretty little integral. And then now, why is it so pretty? Because it's easy to integrate here. So I'm going to bump it up to x cubed. Boom. Flip it and divide, or divide by 3. Still got that 2 in front. Don't forget that constant there. And let's wrap it up. This will be 2/3. What was u? It was x, square root of x. Let's try again. 2/3. Ooh, that looks bad too. 2/3. There we go. Square root of x minus 1. All of that being cubed. There it is right there. That may have just fried your brain. That's the one you may want to watch again. But that is really u substitution in a nutshell right there. What in the world were we just doing? So if you want to put some formulas to it, and I don't want to overwhelm you here, because of the chain rule. Remember, the chain rule is when you have a function embedded in another function. So that's what we were looking at. We were looking at like a square root function. So we were looking at something like, hey, there's a square root function, and inside it, oh, I've got this other function or something going on here. So I had a function in a function. So what happens? Well, when I have a function in a function, the derivative says I can take the derivative and I get this. It's that whole, remember we did the chain rule here, and maybe I should have rewrote it like this. So when I've got this chain rule, what did we do? We took the derivative of the outside function. So I did the derivative of the outside, which was this, and then I did the derivative of the inside, which was this 2x part. So I froze that, kind of took the derivative, put that over there. That's the chain rule which we knew. So check out what's going on here. Well, if I want to integrate this, or if, look at it, there it is right there. If I want to integrate that, what's going to happen? Well, if you integrate this, you're going back to the opposite of the derivative. That's all it is, the antiderivative. Oh, I got too many. There it is. So if you look at that, that's what happens. I go back to where I started, just adding that constant right there. So don't freak out by this. This is just the anti-chain rule, is all it is, and the U just really helps us to clarify, make it easier to see. Pretty cool. All right, let's bring it to trig functions. So I want to spend specific trig functions because they're a little tricky, a little triggy here. Okay, so when I look at this bad boy right here, I've got two trig functions here. So I'm going to pick one of the trig functions, and in my mind, this is e to the x, or e to the cosine x. So that's the trickier looking piece. So I'm going to say that u is actually cosine x. So I'm gonna take a guess here. You could have tried it the other way, and a lot of times it's kind of guess and check to see what happens. And then what is this nice? Well, what is the derivative of cosine? The derivative of cosine is negative sine x with respect to x. So was this a good guess right off the bat? Let's take a look here. Sure. I think this is going to work out well for us. So if I leave this sine x here, and I've got e to the u, which is what I want, which is good. I still have this dx. Well, what was dx? Oh, I was going to divide by that. So maybe I should still show that step. Sometimes I don't show that step, but that may be, we may not be there yet. If you are, maybe you can kind of see it canceling in your head, which is awesome. That's our goal. But the dx is really du over, so du over sine, negative sine of dx. So in this case, I've got the sine of x, eu, dx was du over negative sine x. And this is my canceling part. This is where things gotta cancel, and I can see it, boom, boom, my sides are gone. Careful, that negative stays, and in fact, I'm going to pull that negative out. It's like a -1, like a constant, and you've got the integral of e to the u du. Wow, that's pretty awesome. Let's finish this out just for some closure. If you integrate e to the u, what do you get? You get e to the u. I can integrate e all day. That's just awesome. Don't forget your constant, and then don't forget to plug your u back in there, which was cosine. So really, this was this, and you can check these. You can take the derivative of this. The derivative of this has to give you that because I'm integrating it. And yeah, when you take the derivative of e to the cosine x, what's the derivative of cosine? You know, it's e to the cosine x, and then that little part's the sine part. So yes, it works. We're happy. We're good to go. Awesome. Let's try this next one. So I don't see two trig functions, so I'm guessing it's probably the angle that I'm going to want to put some u on. So that sounded so weird. So u is what? U is 2x plus 1, and then the derivative of this is just 2 dx. If we solve this thing for dx, I'm looking at the dx is just 1/2 du, or du over 2, however you want to write that. And if I set this up, I'm going to say, yeah, it's the cosine of u, which is good. The dx is this 1/2 du, so that's good, so I replace that. And then what do? I just bring that 1/2 in front. And I'm good to go. Set that bad boy up. Let's go ahead and it can get a little tricky here. Just be careful. You know, I'm thinking now, what's the antiderivative of cosine? So what do I take the derivative of? Get this. I take the derivative of sine. So be careful there. I'm taking the derivative of sine and to give me the cosine. And then make sure you sub it back in. When you're done here, we've got 1/2 sine. And then what was my u? I think it was 2x plus 1. Boom. There it is with the c in there. Pretty fun, huh? I like these. These are kind of fun. Almost like little puzzles or something, you know, something kind of cool going on. And remember, we can rewrite things. So maybe I want to rewrite this as, what is cotangent really? Isn't it cosine over sine? So really, I'm looking at this bad boy right here. So sometimes you gotta get a little tricky with it. So if I rewrite this, now what am I dealing with? So in this case, I see two trig functions. I'm going to pick one of them, and I'm going to go with sine in this case. I'm going to go, you could try cosine and see what happens. I'm going to pick sine because I know the derivative of sine is cosine. Just be careful when you take the du here. So the sine of 3x, don't forget it's derivative of sine is cosine, but it's 3x. Don't forget it's chain rule. So that'll be times 3. And don't forget your times the dx here. And let's go ahead and solve for dx here. So I'm going to divide by that hot mess right there, the cosine 3x3. So they cancel. So really, dx is going to be the du over 3 cosine 3x. Holy cow, this is intense. I hope this works out better here. Let's check it out. So I'm looking at that cosine 3x is on top. I'm hoping that's going to cancel somehow. My u is on bottom. Dx is what? It is du over 3 cosine 3x. And again, if you would maybe tried u as cosine, maybe it wouldn't have gone anywhere. Maybe you would have to start over again. I don't want to make you erase twice there, so I figured this would, or I was hoping this would work out. So these cancel right here. My cosines cancel. That's great. Don't forget you got this 1/3 action going on, so it's really 1/3 u to the -1 du, which is awesome. So we got everything worked out. Don't forget how to take the antiderivative of u to the -1. Remember, that's the natural log of the absolute value of u plus some constant c. Then you can go ahead and plug in your u, which is the absolute value of sine 3x, boom, plus c. That was awesome. That is fun stuff right there. So you can see we're getting some more challenging stuff here. Again, practice, practice, practice. This is the only way to do it. Just use substitution all day. All right. Whew, killing it here. So I'm going to give you 3, and I picked these 3 for a reason. They look similar. They all got e to the x in them, so I wanted to do some e to the x's. But sometimes we go use substitution crazy here. So the first one, yeah, I'm going to probably need some use substitution. I see the bottom of the fraction is a grouping symbol, so I'm guessing it's this thing. And when I do that, I'm going to say, yes, this looks like our normal use substitution. What was our du here? Well, derivative of this. Constant goes away. E to the x is just e to the x dx. So it looks like things are going to cancel out pretty nice here for us. Let's just finish it out. So we have it. So my dx is really du over that. So I'm really looking at, I got this e to the x on top. I've got u on bottom. Dx is what? Du over e to the x. And again, it's got to cancel or something's wrong. So boom, they cancel. And I've got the integral of 1 over u du, which again, same as the last problem. What is that? If u to the -1 or whatever, it's the natural log of the absolute value of u plus some c. And then we're going to plug that bad boy in. I know I'm going fast here, but the idea was more the setup on this one. There it is. So a lot of times we're like, hey, yeah, u substitution is great. I love u substitution. I'm going to do it for everything. Do I need u substitution here? No, this is just a straight integral here. So don't freak out. I'm going to mix these into the practice because sometimes it's just this. You can integrate this. So what is the antiderivative of e to the x? It's e to the x. What is the antiderivative? Or if you take the antiderivative of this, it's just 3x plus some constant c, and you're done. That's it. Easy peasy right there. So don't freak out and say, oh, u's got to be e to the x plus 3 because I saw parentheses. It's got to happen. No, that's just basic integration. You're good to go. And even a little bit more intense, again, you're like, oh, here we go. I got some e's and ln's. I better u it up. Well, always try to simplify first. That should be your number one thing. Can I cancel anything out? Can I make it look a little bit better? Yeah, sure. What's going on here? The natural log of e cancels, or really you're writing, you know, that you're bringing the exponent down in front. Is technically what you're doing. You're saying it's 2x times the natural log of e all over x squared. So once you do that, these cancel, which is awesome because now we're looking at the integral of 2x over x squared dx. And then even one of your x's cancels, don't they? So we're really looking at the integral of 2 over x. And hey, back to that natural log again. If you want the constant out in front, you can do that. Or if you just, it's 2 times the natural log the absolute value of x plus some c. So I didn't need u. I don't need you. I just need to simplify it. So always try to simplify it first, and then if that doesn't work, then go to your u substitution. Fantastic. I think there's only one more. problem. I know this is kind of a long one, so I apologize. Because I really want to get you going. You got to do them. You got to do U substitution. These are the trig ideas you're expected to know. So these are things back from pre-calc that hopefully you memorized or had or used them quite a bit. The Pythagorean identity and some of the variations in those double angle identities. So they could pop up anytime. And here's one example. I can't do them all because there's just too many examples. So here's something that could happen. And again, you may groan when you see this. You may look for, this is weird because I got cosine cubed of x. So I can't really use substitute it right now because there's not two trig functions. There's not a messy angle. I'm going to have to rewrite it. Okay, so let's rewrite this bad boy right here. So I've got this cosine cubed can turn into, ooh, that's terrible integrals. Let's try that again. I can go, it's cosine squared x times cosine x. And what's good about this? Well, don't forget your dx out here. Gotta have that. So what's good about this? Well, nothing right now, but it's still cosine times cosine squared is cosine cubed. But cosine squared is an identity. It's a Pythagorean identity, so it's really sine squared x. So this is nice. Now we're getting somewhere here. So I've got cosine x dx, and I'm going to integrate this bad boy. Now I'm ready to try some stuff here. I think I'm ready to give a shot with some u. And again, this could be some guess and check. Maybe you want to try the whole thing. 1 minus sine squared x doesn't work. Maybe you want to try cosine. Doesn't work. It's just something you got to play with. In this case, I'm going to go ahead and use sine of x. And the reason this one's good, the derivative of u is cosine x. So don't feel bad if you try something that goes nowhere. You just got to try again. You got to keep on playing with it till it works out here. So let's solve this. Derivative of sine is cosine, so let's solve it for dx. So I'm going to divide by that. Boom. Those cancel. Now I think I'm ready to plug in my u. So what do I have here? I'm going to have 1 minus u squared, because u is sine. And then I still have that cosine there. In dx, I'm going to sub it in as du over cosine x. Aha! That's why that's nice right there. Boom. Boom. Now I am actually ready to rock and roll. Now I'm in a spot. I'm all in u. So I can go ahead and take the antiderivative. So if I integrate this, 1 turns into 1x. Oops, not an x. Let's try again. 1 turns into 1u. Bump that up to u cubed and divide by that number. And then plus some constant c. Then if I want to finish this bad boy out, let's finish this out. What is u is actually sine. So I'm going to kind of come over here. It's going to be sine of x minus 1/3 the sine cubed of, let's see if it, well, 1/3 the sine cubed of x plus some c right there. Hopefully you can read that. That's supposed to be a 3. There it is. So that is pretty crazy looking. So if I take the derivative of that, it's going to get me back into that right there. Pretty amazing. That's it. I know that last one's tough. Like, that's one you're going to play with and just try stuff for a while. But if you work at it, they kind of get easier and easier as you go. Good luck on this. Peace out.